Hello and welcome to NPTEL online certification course on aero engine gas turbine cycles. I am Chetan Mistry from Department of Aerospace Engineering, IIT Kharagpur. If we consider very first question, if I say what is gas turbine? So basic idea, it says gas turbine, it's engine, that's what is used for the generation of power. It's a fact. If you look at here, this is what is representing gas turbine engine, where we are having this as my inlet, compressor, combustion chamber, turbine, and this is my exhaust. And if you look at here, this is what is my shaft. On left hand side, if you look at, this is what is representing the land based power plant. So we can say gas turbine engine, that's what is used for the generation of electricity. And if we consider, this is what is representing the cut section of the Siemens engine. Here also, if you look at, we are having inlet, compressor, combustion chamber, turbine, and the exhaust. Now if we look at what all are the applications of gas turbine engine, then next application that will come in the mind, that is for the marine application. This marine application also, if we look at, that has application for propulsion as well as for the power generation. Now when I say propulsion, then we need to realize one thing. Here if you look at, this is what is represented the other version of my gas turbine engine. The difference, it can be clearly seen here, what is there at the exit. In terms of exit, if you are looking at, we are having this as my nozzle entry, I say constant area diameter, and other side I say that's what is my nozzle exit. So this is what is representing my conversing passage, and that's what is defined as a nozzle. Now the purpose of this nozzle, it is for the generation of the thrust, which is working on a principle of Newton's law. So both, if we consider, this is what is being used for the generation of shaft power, and this is what is being used for the generation of thrust. So we must realize what gas turbine engine we will be discussing in this course, it is majorly focusing on application for the thrust generation. As we go along, we will see what all are the applications for these gas turbine engines. Now when I say the application for say aircraft, so very first thought, that's what is coming with say jumbo jet, it says A380, where we are having 4 engines, that's what has been placed below the wing. The purpose here, it is for the generation of the thrust. If you look at here, this is representing say smaller version or say lighter version of say 737, which is having 2 engines. Same way, if we look at this engines, gas turbine engines, they are also having application for the military purpose, where we are using these engines for the fighter aircraft. The purpose for these engines in aircraft, especially for the commercial aircraft and for the military aircraft, they both are different. Their working principle is same, but the operational characteristics and operation of mode, that will be different. This, if you look at, that's what is representing the other version of gas turbine engine, that's what is called propeller based gas turbine engine, where we will be having propeller that will be placed, it may be placed on the front side, I say that as a turboprop engine, and here if you look at, that's what is being placed on the rear side, that's what is say by say turboprop engine, that is used for puller and pusher kind of configurations. So this gas turbine engines, what we are discussing at this moment, that has wide range of application in terms of say aircrafts. Same way, over the year, people they found different application for different purposes. If you look at here, this is what is representing UAV, that's what is your unmanned aerial vehicle, where you will be having your gas turbine engine. This gas turbine engine, that's what will be rotating my propeller, and that's what is generating the thrust as per my requirement. If you look at here, this is what is representing UKAV, that's what is unmanned combat aerial vehicle, where we will be having our gas turbine engines, that's what is being placed. At the same time, if we look at, there are other purpose of this aero engines. One of them, it is for say helicopter. So, here if you look at this engine, what we are looking at, that is also gas turbine engine. This gas turbine engine, that is what is being used to rotate the shaft. That shaft is connected with this fence, and this is generating the lift for the helicopter. At the same time, we are also having gas turbine engines for the application of say military. We can say for the generation of the missiles, we are using this kind of aero engines. Now, other kind of thought process, that is what is going on in terms of development of drones, as well as for the meat, which is being used for the surveillance purpose, which is also being used as a target. So, there are special interests of these gas turbine engines for various kind of applications. So, if we consider gas turbine engine, it is not now limited with the generation of power or generation of electricity or for the application of process industry. It is also having application for the aero engines. When we are talking about aero engines, they have application for say your commercial aircraft as well as for fighter aircrafts, and there are different other special kind of applications. That is what we have discussed here. Now, let us go in terms of detail for this course. So, it says we need to have some fundamental understanding of introduction to aircraft propulsion. So, those students who are undergraduate or postgraduate or PhD scholars or maybe industrial professionals, they must have gone through the basic course if they are having say aerospace engineering as a specialization. So, where we have discussed many things in terms of aerospace propulsion. If you are not having this background, do not worry about that part. We are having most of these gas turbine engines, their basic working principles that are based on say your thermodynamics. Here I have written this course is required engineering background of thermodynamics. So, thermodynamics course, if we look at, they are having different branch, they are having different thermodynamic course. If you consider say physics, chemistry, maybe chemical engineering, mechanical engineering, they all have this thermodynamics as a basic course. Even you have studied this thermodynamics in your class 11 and 12, but realize one thing, here we are discussing gas turbine engine where the thermodynamics we are considering as an applied part, and that is the reason I say we need to have the background of engineering thermodynamics. So, do not worry about that, maybe as and when required I will try to put the basic fundamentals for this thermodynamics. At the same time, our working fluid is air, and if we consider air, it will be having the compressibility effect, and looking to this compressibility effect, it says we need to have detailed understanding of your gas dynamics or say compressible fluid flow. So, if you will be having the background of compressible fluid flow, that also will be helpful along with your fluid mechanics fundamentals. If we consider here, now this course, it has been designed dedicatedly for UG students, for PG students as well as for the working professionals. This has been specialized course in its sense. So, we are having number of courses which are available for the aircraft propulsion, but at the same time there is no specific course which is discussing the aero engine gas turbine cycle, which has a special interest and special requirement for the future developments. So, based on that, this course it is been divided in 12 weeks. If we look at very first week, we will be discussing about the introduction to gas turbine engines, special application to aircraft. Then we will be discussing about the very important terminology, that is what is called thrust. We will be discussing about the criticism of the engine in terms of propulsive efficiency, in terms of thermal efficiency, overall efficiency, specific fuel consumption, total equivalent power, total shaft power, equivalent specific fuel consumption, aircraft range, endurance range, everything. That is what we will be discussing. This all terminologies what we are discussing, that is what will be remain throughout our course, and that is the reason why it has been kept in your introduction part. Now, let me put one point here. This course is a certification course, and that is the reason why you need to appear for the assignments. So, every week we will be having one assignment, that is what will be of MCQ kind of questions. where you will be having say continuous evolution. Based on this evolution, you will be getting your grades. Now, in second week, we will be discussing about the component performance. We will be starting with very fundamental approach, that is what is called control volume approach for inlet diffuser, compressor, combustion chamber, turbine, exhaust nozzle. These all are the basic components of our gas turbine engine. Then we will be discussing about the ideal component performance as well as actual performance of these components. That is what has been criticized in terms of adiabatic or polytropic efficiencies. We will be discussing about say shaft energy balance. We will be discussing about what all are the use or special need of these components for say aircraft engines. In week 3, we will be starting with very fundamental engine, that is what is say turbojet engine. So, we will be discussing about the basic introduction to turbojet engine, single spool configuration, multi-spool configuration. We will be discussing about the thermal cycle analysis of single spool and two spool turbojet engine without operation of afterburner. Then we will try to understand what all are the effect of various parameters what we have selected for the cycle analysis on the overall performance of the engine, and that is what will be helpful to us in order to understand how your gas turbine cycle analysis initially been analyzed with. In second version, in week 4, we will be discussing about the operation of afterburner. We will be discussing the thermal cycle analysis of two spool turbojet engine with afterburner. We will be discussing both ground as well as flight condition. When I say afterburner, you can understand this afterburner that is having special application when we are discussing about the military aircrafts, where this afterburner is playing very important role. These afterburners, they were also being used for commercial aircraft, but at this moment these are not under operation. But the basic understanding of this afterburner with turbojet engine configuration, it will make much sense. In week 6, we will be discussing about the need of second kind of engine, that is what we are defining as a turbofan engine. We will be discussing about the classification, construction details, high bypass ratio engine, low bypass ratio engine. We will be discussing about say single spool configuration. Again, for this kind of engines also we will be doing the thermal cycle analysis. We will be discussing what all are the parameters which are affecting the performance of these engines. Along with this, all these weeks what we are discussing, we will be solving the numericals that will give more understanding, detailed understanding how the cycle analysis that can be performed. For week 7, we will be discussing about the unmixed two spool configuration, where we will look at, suppose if we consider the fan and low pressure compressor, they are on single shaft. Fan that will be driven by low pressure turbine and the compressor will be driven by high pressure turbine. So, these are the different kind of engine configuration which are under operation. So, in order to understand what all are the effect of these parameters on the performance, we need to go with the detailed cycle analysis. So, we will be doing detailed cycle analysis for these engines also. Now, recent trend, if you look at for most recent engines, they are gear turbofan engines, and we also will be discussing about how these gear turbofan engine, they are different from the conventional engines and how their performance, that is what will be helping in order to meet the future requirements in terms of our pollution, in terms of performance, in terms of say enhancement of the performance, in terms of specific fuel consumption. So, we will be discussing cycle analysis for gear turbofan engine in comparison with the conventional engine. So, that will give more clarity. In week 8, we will be discussing about the 3 spool configuration. This is what is a specialization by Rolls-Royce. They are the only proprietary rights for this 3 spool configuration. We will be discussing about the mixed configuration as well as unmixed configuration for this kind of configuration. That is what is being used for say aircraft engines. Now in week 9, as and when we are discussing about these aero engines, we must realize the thing that these engines are under continuous development. We are about to reach 100 years very soon for the development of these gas turbine engines application to aircraft, and over 100 years lot of development activities which are been going on. At this moment also people they are working for the future engines that will be coming in maybe 2035, 2045, 2050s. For that the development activities are going on. Some of them are say intercooler and regenerator kind of configuration. We are having say variable cycle engine which we can say 6th generation aircraft. Now the recent trend is moving towards the hybrid engine. So we will be discussing all these engine configuration in detail with some configurations which in open literature people they will not be disclosing because of their proprietary nature, but with detailed understanding for last 8 weeks what we have discussed, we will try to analyze, we will try to understand in a specific way. That's what is the speciality of this course. Then we will be discussing about the next kind of engine configuration, that's what is called turboprop engine. We will be discussing what all are the advantages and disadvantages of this turboprop engine. We will be analyzing this turboprop engine for single spool and 2 spool configuration. Again we will be discussing the comparison with turbojet, turbofan engine and this turboprop engines. In week 11 we will be discussing about the turboshaft engine. These engines as we have discussed they have application for helicopters, and in future they will be having some special applications too, and looking to that we need to discuss that in detail. So we will try to discuss the cycle analysis for this kind of engine configuration. Now after analyzing all these engine configurations starting from turbojet engine, turbofan engine, turboprop engine, turboshaft engine, we need to have detailed understanding how this engine that's what is performing under design and off design condition. When I say design condition means it is one condition, that's what is for which the engine it is been designed. When I say off design condition, that's what is when the engine is working under different operating conditions, and for that we need to have detailed understanding about the component matching as well as say engine testing. We will be discussing the details about the operating map of compressor, turbine operating map. We will be discussing about the variable area nozzle performance under off design configuration. Then we will try to put the component matching for single spool turbojet engine. We also will be putting some discussion in terms of how the engine testing that's what has been performed by different companies. So in overall if you look at this all 12 weeks, you will be having great journey in order to understand the gas turbine engines which are being applicable or that will be helpful for understanding for application for future aircraft engines. Now in terms of reference books, so I prefer to say your zeroth reference that's what will be the class notes or the lecture notes. If we consider this class notes and lecture notes, then we need to realize this course it is been designed for the special application, that's what is for the fundamental and that's what is a basic course for undergraduate students. Slowly when we will move ahead they will get the more clarity, and this course also is applicable or may be helpful for the working professionals. So it is like fundamental, low level, high level, medium level kind of course. Okay. Now these are the some of the reference book which I recommend. If you look at very first book, that's what is by Cohen and Rogers, that's what is very fundamental book in order to understand these gas turbine engines. The book by Al Sahid, he has also discussed the engine configuration in detail, that is also one of the good book. Said Faruqi by Aircraft Propulsion book, that is also a good book. The book by Peterson and Hill, that is also a good book in terms of learning the basic fundamentals. Book by Mattingly, for say elements of propulsion, gas turbines and rocket. That is a good book to recommend for this course. Close, a book by Professor Bhaskar Roy from IIT Bombay. That is also a very good fundamental book. Book by Oates, Horlock, Kurz. These all books are discussing the gas turbine engine application to aircraft in a different way. They all have different contents. So I tried to condense, I tried to compile all these books, detailed literature available in research papers, and based on that this course it has been designed specially for the special requirements. So I prefer to go with this reference text. Now if we are looking for say additional learning resources, we are having a software that's what has been developed by Kurz. It's called GasTurb. Second, I recommend that's what is AED system. That's a software which has been developed by Mattingly. And the third software that's what has been developed by SWRI. It is NPSS. So in order to analyze the gas turbine cycle, there are different open source resources available. If you look at, these are some of the standard softwares which are available. Some of them they are available. If you look at say GasTurb, they are giving the evaluation version for the students for 14 days. NPSS, they are giving the evaluation version for 45 days, and Mattingly, it is available with his book. Now all engine manufacturing company, if you name say General Electrics, Rolls-Royce, Pratt and Whitney, Siemens, Honeywell, Safran, MTU engines, they all companies they are having their own code for analyzing the gas turbine cycles. These are some of the references which you can use in order to analyze the gas turbine cycle, in order to understand the gas turbine cycle and performance in detail. Now what all will you be gaining after doing this course? So it says on successful completion of this course, you will be able to understand the fundamentals of aero engine gas turbine cycles and their applications, fundamentals of parametric cycle and prediction of engine performance. You will be understanding the different existing engine configuration, their thermal cycle analysis, their operation, what all are the advantages and disadvantages or the limitations of the engine. After understanding all this detail, you will be able to explore possible innovative gas turbine cycles for future aero engines with expected performance parameter. That's what is the need for the future engines. After doing all this, I say you will be able to do first cut gas turbine cycle analysis and performance prediction for the recent and future aero engines and use this data for various engine component design. This also will be helpful to you for predictive and preventive maintenance in order to do your performance enhancement, etc. Now the recent trend is moving towards say digitization, and this gas turbine engine you cannot omit from this digitization. That's what is called digital twin of the engine. Use of your artificial intelligence, use of your machine learning, that all that can be applicable by this gas turbine engine manufacturing companies. So what last point I am putting, that's what is applicable to that. And you must realize, if you are having the background of all this knowledge about the gas turbine engines application to aircraft engine, it will be very easy for you to move forward. If we are talking about the preventive and predictive maintenance and performance enhancement, that's what will be very much helpful to MRO companies. That's what is say maintenance, repair and operation. So in overall, if you look at this whole course content, you will realize this is what is a unique course. Basically, it is designed for all professionals. Now let me introduce the internship program. So NPTEL, they have started an NPTEL internship program, that is to encourage the toppers of the NPTEL course to spend there some time with respective course instructor, you are most welcome for the internship at IIT Kharagpur. This internship could be of maybe 4 weeks, 6 weeks, 8 weeks, 10 weeks or maybe 12 weeks based on the mutual convenience and availability of the course coordinator. NPTEL will provide the stipend to the students as per the norms decided by the NPTEL program committee. This internship is provided with the certificate on the successful completion of internships. So, you can understand this is what is giving the unique opportunity for all of you to go for this internship program, enhance your knowledge and fulfill the requirement for the future demand in terms of job, in terms of helping the nation. So, this is what all we will be discussing about say our NPTEL certification course on aero engine gas turbine cycle. Here we are talking about say development of the engine. Now, this development of the engine, if we look at, let's try to understand what all is the use, what all you will be studying here in gas turbine cycle. Okay. So, if we look at very first thing, that is what is I am defining as a mission. Mission in the sense what all are my requirements. Suppose if I consider I am planning to design the aircraft engine for the specific aircraft, then I will be having certain mission. Say I want to fly from some distance to other distance, I need to fly at particular speed, I need to have this engine to be very efficient in terms of fuel economy, I want this engine to be environmental friendly. All those we are considering as a mission for the aircraft engine. Now, based on this mission, very first thing this engine manufacturing company, engine design companies they are doing is the cycle analysis. So, you can understand in mission it says I am looking for specific thrust, I am looking for special say thrust to weight ratio. In order to meet this requirement, we need to go with basic cycle analysis, thermal cycle analysis, where we are considering our engine as a black box at initial part. Based on that, we will try to configure the engine components, which includes say fan, compressor, combustion chamber, turbine, nozzle, all those components. Now, we will be evaluating this performance of all these components, and based on that we will try to reintegrate with the cycle analysis. After doing that, we will be checking with whether it is meeting with the requirement of my thrust to weight ratio, because for aero engines this thrust to weight ratio, that is what is very important. Based on that, we will be checking whether it is meeting with the requirement or not. If not, then we will be going with the scaling of our all components, then we will go with say engine configuration. Again we will be assessing our performance, then we will be checking with the cycle analysis. After doing all this, we will be going with say finalization of my component design, each components of this gas turbine engine. For that, it may require to go with say component testing. This component testing again we will be assessing and we will be putting that to our engine configuration requirement. We also will be evaluating our say component performance, and that also we will try to integrate with our engine configuration. This all what we are discussing, that is what is called my preliminary design. So, for the development of gas turbine engines, before a decade it was taking 10 years almost for any engine manufacturing company, because of development of technology, because of availability of the resources, computational power, our industry 4 readiness. That is what has reduced this cycle for the development of this engine to few years. That also is not less than 5 years. Now, after doing all this, we will be going with the manufacturing of this engine. once we are doing our manufacturing, we will be having the integration of this all components, and based on that we will be going with the engine testing and certification. So whole this cycle, as we have discussed, that's what is taking almost 10 years. Now it is taking 5 years. So you can understand what I mean to convey here is the cycle analysis. This is what is an important part, or you can say it is the main requirement for the development of our aero engine, and that's the reason why this dedicated design course it is been developed. It says aero engine gas turbine cycles. Okay. So here we are stopping with the first lecture, introduction to our course. Now from next lecture we will try to move in detail for all other components. Thank you very much for your kind attention. If you have any query, you can communicate through email, or we will be having online session where we will be discussing about what all are your queries, what all you are looking for, what all you want to learn with. Thank you very much.